3. Modular arithmetic. The concept of modular arithmetic was developed by Gauss at 1801. So imagine that in a 12-hour clock system, 15 o'clock is 3 o'clock. 21 hours from noon is 9 o'clock. Since the clock number starts over after it reaches 12, this is called arithmetic modulo 12. So we would write 15 is congruent to 3 mod 12, and 21 is congruent to 9 mod 12, and 33 is congruent to 9 mod 12 as well. So for a positive integer n, two integers a and b are said to be congruent mod n, written as a is congruent to b mod n if their difference a minus b is an integer multiple of n. So for example, 18 is congruent to 4 mod 7 because 18 minus 4 is 14 and 14 is 2 times 7. Minus 20 is congruent to 13 mod 11 because minus 20 minus 13 is negative 33, which is minus 3 times 11. 19 is congruent to 3 mod 2 is because 19 minus 3, which is 16, is equal to 8 times 2. So you see here in these three examples, I'm having a 7-hour clock. So 18 and 4 will be at the same position of the clock. Here I have a clock with 11 hours. So negative 20 and 13 will be at the same position. And here I have a clock with 2 hours only. Then the 19 o'clock and the 3 o'clock is the same thing. Once again, a is congruent to b mod n if their difference a minus b is an integer multiple of n. We can think in this way. So here this is a simple division. I got 16, which is what we call the dividend, and I divided by 3, I call it the divisor. So the quotient is 5, and 3 times 5 is 15, and then the remainder is 1. So we consider it this way, then you think about like a minus b is actually the dividend minus the remainder. So this thing is the extra bit. You realize that 16 minus 15 is 1. So on the other hand, 16 minus 1 would also be 15, right? So this 15 is of course divisible by 3. So this thing is divisible by the divisor. So this is one way that we interpret the understanding of modular arithmetic. So what's the remainder of 15 divided by 12? We know that is 3. So we say 15 is congruent to 3 mod 12. And you can also think that 15 minus 3 is 12. So 12 is 1 times 12. We want b to be the remainder, and hence this b is greater than or equal to 0 and always less than n. So here you will have some exercise on modular arithmetics. Right now, please pause this video and go to Moodle to work on the exercise. And then I'll see you in the next video.